Hi Snowden students. Today we're going to be going over the chi-square test. If I'm going too fast, feel free to slow the video down or pause it. You should find all of the materials for this assignment in Google Classroom under chi-square breakfast. So our objective for today is to learn how to apply a chi-square test to data. And we're going to do this by going over a research question, collecting our data, summarizing it, doing some statistical analysis, and finally reaching our conclusion. So first, let's start with the research question. We're going to start with the research question and figure out how we're going to answer it with the chi-square test. So first, what do we want to answer? Well, Mr. Roundtree is Snowden's high school headmaster, and he's a little bit concerned. He's concerned about student health. So he goes to Miss Maya Feller. She is a nationally recognized nutritional expert. She's accomplished a lot. She's written her own cooking book right here. She's done a lot of interviews. And what's really cool is she has a lot of articles in her press that might help if you aren't sure what kind of foods to eat or you have a couple of questions. So Mr. Roundtree goes to Miss Maya Feller, and he says, Miss Feller, with the pandemic, I'm concerned about student health. What do you think I should do? She answers, well, do you know if your students eat breakfast? Now, according to one of her articles, she recommends that you should eat breakfast within at least 2 hours of waking up. The best time of day to eat breakfast. And so now we've got our research question. Do enough students at Snowden International High School eat breakfast? Let's move to our second step, collecting the data. Mr. Roundtree needs to ask students if they eat breakfast. But there's two problems to this. The first problem is that at Snowden there's 439 students. Asking each of them if they eat breakfast is a lot of work. If you were going to try to ask each student in this population, it would be so much work. So instead, you can take a sample. A sample is a set of individuals or objects collected or selected from a population, so you're no longer asking everyone. Instead, you might be asking just these two rows. The second problem is that Dr. Roundtree is very busy, and he can't really focus too much time on this. So instead, he goes to Dr. Durand, and he says, Dr. Durand, can you please ask your IB students if they eat breakfast? But Dr. Durand doesn't teach 9th and 10th graders, so our research question has changed a little bit. He only teaches 11th and 12th, so we're going to see do enough 11th and 12th grade students at Snowden eat breakfast. So Dr. Durand put out a poll, as you saw in Google Classroom, and he asked his students, and he collected all of this really cool data. But it's a little bit confusing because if we were going to look at the data, and if we were going to represent each person who eats breakfast as a smiling breakfast plate, and each person who doesn't eat breakfast as a frowning breakfast plate, right now, the data kind of looks like this. It's all over the place. We have it, but we just haven't organized it. So the third step is going to be to summarize the data in order to understand it. Dr. Durand needs to count how many students eat breakfast and how many don't eat breakfast according to each grade. So this is where, in Google Classroom, you need to go to the chi-square breakfast assignment. Here, hasn't been posted yet, but it will be as you're watching this when you watch this video. And you're going to open the Excel that looks like this. Now there's one key difference between your data and my data. My data here, the no's and the yeses and the grades, is different from yours, which means that when you're doing this along with me, you can't just copy down the numbers that I put in the video, but you need to apply your own functions to get the answers. So let's go to our third step, summarizing the data. Does the 11th and 12th grade at Snowden International High School eat breakfast? That's our research question. So first, we need to compare the grade level responses by splitting the data into 11th and 12th grade. And there's one really easy way to do this. All you need to do, so this is the column B is the grade of the student, and this is their response to if they eat breakfast or if they don't eat breakfast. This is the first student's response, the second student's response, the third student's, and it keeps going down. And as you can see, we have a mix of 11th and 12th grade, a mix of yeses and nos, eats breakfast or don'ts, and we have 66 responses. So our sample is 66 responses. But we want to split this according to the grade level because we're going to look at each grade. So you can order this data according to the grade level by using the data sort function. You would highlight columns B and column C, and then you would go to data, sort range. Make sure that you check this box that says data has header row, because this means that we're keeping the grade and the breakfast in place, and then do A to Z. If you don't check this box, then it's going to move the headers, and it's going to be harder to interpret your data. So we want to make sure data sort range, we check this box, and then we do sort by grade. And now all of the responses have been sorted with 11th grade first and then 12th grade next. So we've split the data into 11th and 12th grade. Our next step is to count how many students answered yes or no to eating breakfast. Now we went over this a little bit in class. We use something called the COUNTIF function. We're going to put what we calculate into these two cells because this is our observed. So we're going to look at our sample and we're going to see the number of observations we got for yes and the number of observations we got for no. So starting with the first one, remember you can't just copy down the number I write because your data is different. There's a couple of ways to do this, and I'm going to go over each one, and then I'm going to only focus on one for the rest of this. What you can do is you can do equals count if. This function comes up. It asks for the range. Right now we're just doing 11th grade, so I'm only going to highlight all the cells that have 11th grade. Oh, this is 12th grade. I don't want to highlight this, so I'm going to just highlight all of the responses that are from the 11th grade. Now a comma. And then what are we looking for? Well, we're looking for if they responded yes. So you do a double quote. Yes. Oops, that's not capitalized. Yes. It's capitalization is sensitive, so make sure that it's exactly as it is here. You don't want to put yes in all caps or even a yes with the caps at the end. We just put the regular yes and quote and parentheses. Now what I like to do before I click enter and submit this function is I will highlight it, I will copy it, and then enter, and this gives us the number of times that yes appears for the 11th grade. And then for the no's, instead of doing all of that, I just hit paste. And it does the same C2 to C41, which is where we ended for the 11th grade. And then instead of doing yes, I can edit my function up here, and I'll make it no. 22. Okay. So now we have our observed for the 11th grade. Now we want to do that for the 12th grade too. So I'll do equals count if the range. Well, we're not doing any of the 11th grade, we're just doing the 12th grade. So I'm going to start here as the 12th. I'm going to start at the 12th grade and highlight all of the 12th grade. And now we're looking at the yeses. So I'll do comma, yes, and end parentheses. Now, another thing you can do is you can take this cell and you could just copy it, and then if you paste it here, it'll paste exactly what's in here in this cell to the next one, but it will change the range. So you see how it goes from C42 to C67 to C43 to C68. So you would need to manually change the range back to what you want, as well as whether or not it's yes or no. But one way you can keep the range the same regardless of when you copy or paste it is you could put a $sign in front of it, both the letter and the number. And then when you copy this, instead of, see how it's C42, but this, when you copied it, it was C43. Now when you copy it and you paste it here, paste, now this keeps the same range. And then we'll just change this to no. So now this has calculated how many times no appeared for the 12th grade. So those are just two different ways that you can calculate it. I like to go with whatever's the simplest. I don't want to have to retype the function all the time, so I copy the function and then I just change what we're looking for. Okay, awesome. So we've counted how many times students answered yes or no to eating breakfast. That's done. So now we've taken the data and we've organized it. It no longer looks like this mess, it looks kind of like this. So we go to Ms. Feller and we say, look, this is what we found. Based on our sample, in the 11th grade, 18 students eat breakfast and 22 students don't. And in the 12th grade, 7 students eat breakfast and 19 students don't. But remember, our research question is, do enough 11th and 12th grade students at Snowden International High School eat breakfast? Well, maybe Ms. Feller says that at least half of your students should be eating breakfast. So now enough, we've turned it into a number, needs to be at least half. In order to answer this question with a positive, yes, enough students at Snowden eat breakfast, it needs to be at least half. And this is where we move on to the statistical analysis. We need to perform a chi-square test on the data to determine if at least half of the students are eating breakfast. But what does this look like? What does it look like if half of the students ate breakfast? Well, remember, we divided our data up where a smiling pancake eats breakfast and a frowny eggs and bacon, ham, doesn't eat breakfast. So a smile is eat breakfast and a frown is one that doesn't eat breakfast. And we're just going to focus on the 11th grade right now. So we have our observed, we have the numbers that we counted in our sample of just the 11th grade, those who ate breakfast and those who didn't eat breakfast. Remember, this is just our sample. And now, Ms. Feller says that we should have at least, so even though this is our sample, this next part might look a little bit overwhelming. It's okay. Remember, our sample just came randomly from the whole population, so we didn't test the entire school. We tested just a group of students. So what does it mean for us to have at least half of, I'm gonna move this over, and move these two tables over. Put them here. So what does it mean for at least half of our students to eat breakfast? What would that look like if that's how it was in our sample? Remember, this is our sample. In order to calculate it, we would need to take the total amount in our sample. In this case, it's just 18 yeses and 22 nos. So our total sample size for the 11th grade is 40 students. Now, if at least half of the students eat breakfast, well, half of 40 is 20 yeses, which would mean that the other half is 20 nos. And again, the total for each one becomes 40. So we have, this is what it should look like if half of the students ate breakfast. But this is what it currently looks like. But we need to remember that if this is just a sample, I've highlighted just our sample in the white outline, and this whole thing is our population. Our sample is random. Our sample might not be the most accurate to our population. And if this is what our sample looks like, just what's outlined in white, what if, say, instead of picking like one of these plates, say that we had instead just randomly picked one of these yeses. Instead of picking just randomly one of these nos, we had picked, because our sample is random, we could have chosen anything. We had picked this plate instead. That would now make our yeses 19 and our nos just 21. And then what if we had done that again? Instead of randomly picking this no, we had just randomly picked this yes. I would now make it from 19 to 20, and our no's from 22 to 20. And now our observed is our expected, but as we saw, because our sample is random, that's not always the case, and we're going to have something like this where it might look different from the expected. But this is the most important takeaway for the chi-square test. At what point is the difference between what we observe compared to or versus what we expect random? Is the difference between what we observe, the 18 yeses and 22 nos, is that just the difference between what we observe and what we want to get, the 50, at least 50%, the 20 and the 20? Is the difference between these two random, or is it a pattern? And that's what the chi-square test aims to look at. It returns a probability value, which is the chance that that difference is random. So, for example, if the probability value is 0.57, it means that there is a 57% chance that that difference, the difference between this sample and what we expect this sample, is random. But we have to choose a cutoff. What p-value is the cutoff? What probability is the cutoff? And we've decided the cutoff traditionally is 0.05, 5%. So if the probability value is 0.05 or greater than 0.05, or I guess the randomness is greater than 0.05, the difference between the observed and the expected is random, and they are not statistically different. So if it's 0.68, 0.79, even 0.06, or even 0.05, this should be a greater than or equals to sign. They are not significantly different, and the difference between the two groups is just random. But if it's less than 0.05, if it's 0.048, 0.02, 0.0001, the difference between the two groups is random, and they are significantly different. This should say is not random. Sorry about that. The difference between the observed and the expected, the two groups, is not random, and they are significantly different. Okay, that was a lot, but that's the key takeaway. The chi-square test determines at what point is the difference between what we observe and what we expect random. So then, let's apply this and get our p-value. We decided that the expected is going to be at least half. So it's going to be 20 yeses and 20 nos. So our expected is going to be at least 20 yeses and at least 20 nos. And remember, we decided that because we knew that our total sample size for the 11th grade is 40 students, and we want at least half, or 50%, that's 50% of 40, to be yeses in our expected. So now we're going to try to get the p-value to determine if at least half of the 11th and half of the 12th grade eats breakfast. And the way that we find the p-value is we do equals chi-test. We looked at the observed. We highlight the observed, what we saw in our sample, comma, and then we'll highlight the expected. And parentheses, enter. And now this is our p-value, 0.527. So take a minute and think about what that means, having a p-value of 0.527. If the p-value for the 11th grade is 0.527 or 52.7%, there is a 52.7% chance that the difference is random. There is not a statistically significant difference between the observed and the expected, or there is not a statistically significant difference between the 11th grade, between having 18 yeses and 22 nos, and what we would expect, having at least half being yes and at least half being no. So in that way, we can go to Ms. Feller and say at least half of the 11th grade eats breakfast. This is normal. We shouldn't be concerned about how many students eat breakfast in the 11th grade. Now let's look at the 12th grade. The difference is a little bit bigger. Is this due to random chance? First, remember, Ms. Feller said that there needs to be at least half of the students need to eat breakfast. We'd expect half of the students to eat breakfast. So first we need to find the sum. And you could just add the two numbers. I like to use functions. So the sum of our sample for the 12th grade is just 26. And now if at least half of the sample and the expected needs to eat breakfast, then we'll take 26 divided by 2. Or you could do times 0.5. This is just 26 times half. And then you would do that again here. 26 times. You could do it either way. You could click the cell or you could type it in. So we know that this is what we would expect if half the students ate breakfast, and this is what we collected from our sample. So is the difference between these two groups random? Let's check. We'll do equals chi-test. Our observed is here. That's the sample. And our expected is here. We get 0.0186. Take a second to think about that. That's our p-value. What does it mean? The p-value for the 12th grade is 0.019, or 1.9%. There is a 1.9% chance that the difference is random. There's a 1.9% chance that the difference between these two groups is random. That is too low. It is lower than our cutoff of 0.05. So there is a statistically significant difference between the observed and the expected, or there is a statistically significant difference between the 12th grade students and what Ms. Fowler says is healthy. And now our last part, and the most important part, is why is this significant? Our research question is, do enough 11th and 12th grade students at Snowdon eat breakfast? Well, based on our statistical analysis, enough 11th grade students eat breakfast, but not enough 12th grade students eat breakfast. At Snowdon, the number of 12th grade students who eat breakfast is too low. And maybe we should do something in the school to encourage more 12th graders to eat breakfast. There's always a purpose to these statistical tests. And in this one, we were able to conclude whether or not the 11th or 12th grade, the number of students at Snowdon eat enough breakfast. Thanks for watching this video. Put a lot of time and thought. I hope you like the designs and are able to understand everything on here. If you don't, please email us, ask us questions, and give us feedback. Thanks.